4.3, writing equations of parallel and perpendicular lines. We're going to start with parallel lines. Parallel lines have the same exact slope. So as long as you can find the slope of one of the lines, another line that has the same slope means that it's parallel to the first. If we look at these three lines that are on this coordinate plane, we're determining which of the lines are parallel. The blue line, we're going down 1 and then to the right 4. So that slope is negative 1/4. The red line, we're going down 1, so it's negative 1 over 1, 2, 3, 4. So that slope is negative 1/4 as well. For the green line, we're going down 1, 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's negative 1/5. So the only two lines here that are parallel are lines A and B. When you write parallel, you can write out the word parallel, or you can do two lines that look like lowercase l's right next to each other. B says line A passes through negative 5, 3, and negative 6, negative 1. Line B passes through 3, negative 2, and 2, negative 7. Are the lines parallel? We're going to find the slope of each. If the slope is the same, then they're parallel. So the slope of that negative 5, 3, and that negative 6, negative 1, we're going to do negative 1 minus 3 all over negative 6 minus negative 5. This is going to give us a negative 4 over negative 1, which is 4. For the 3, negative 2, and 2, negative 7, we're going to have negative 7 minus negative 2 over 2 minus 3. These two turn into addition, so this is going to be negative 5 over 1, negative 1, which is 5. These two do not have the same slope, so they are not parallel. For example, 2a, we're writing the equation of a line that passes through 5, negative 4, that is parallel to the line y is equal to 2x plus 3. So this one, our slope for this line that we are given in slope-intercept form is 2. And if it passes through 5, negative 4, we're going to use point slope form. So y minus y1 is equal to slope times x minus x1. So this is going to be y minus negative 4 is equal to 2 times x minus 5. We are going to add these two, so y plus 4 is equal to 2 times x minus 5. From here, I'm just going to solve for y. Since my line that was given for me for that other line is in slope-intercept form, I'm going to put this one in slope-intercept form as well. So I'm going to distribute the 2. So y plus 4 is equal to 2x minus 10. I subtract that 4 from each side, and I just am left with y is equal to 2x minus 14. For B, we're writing an equation of the line that passes through negative 4, 2, and is parallel to the line y is equal to 1/4 x plus 1. Parallel, same slope. Our slope is going to be 1/4. So again, use your point slope form. Y minus 2 is equal to 1/4 times x minus negative 4. The two negatives turn into positives, so we have y minus 2 is equal to 1/4 times x plus 4. We're going to distribute the 1/4, so y minus 2 is equal to 1/4 x plus 1. We add that 2 to each side, and we just have y is equal to 1/4 x plus 3. Perpendicular lines have reciprocal opposites for slopes. So if you look at this example, we have one line that has negative 2 as a slope and another that's 1/2 as a slope. These two are perpendicular since their slopes are opposites and reciprocals, and they form a 90-degree angle when the two lines intersect one another. For example 3, we're determining which of the lines, if any, are parallel or perpendicular. So for line A, we have y is equal to 4x plus 2. Our slope for this one is 4. Line B, we have x plus 4y is equal to 3. In order to get y by itself, we're just going to subtract the x from each side. So we have 4y is equal to negative x plus 3. We divide each side by that 4. And we get y is equal to negative 1/4 x plus 3/4. So our slope for this one is negative 1/4. And line C, we have negative 8x minus 2x, or sorry, negative 8y minus 2x is equal to 16. So this one I'm going to add the 2x to both sides. I have negative 8y is equal to 2x plus 16. Then I divide each side by that negative 8. So y is equal to negative 1/4x minus 2. So line A is perpendicular, is an upside down capital T, to line B and line C. We're doing the same thing for B. For line A, we have 2x plus 6y is equal to negative 3. We subtract that 2x from each side. We get 6y is equal to negative 2x minus 3. Then we divide each side by that 6. So y is equal to negative 1/3 x minus 1/2. So our slope for this one is negative 1/3. For line B, we have y is equal to 3x minus 8. Our slope is simply 3 here. And for line C, we have negative 6y plus 18 is equal to 9. We subtract the 18 from each side. We get negative 6y, is equal to negative 9. We divide each side by negative 6. And we get y is equal to 3/2. So our slope for this one is 0. So the only lines that are perpendicular is line A and line B. So line A is perpendicular to line B. Again, perpendicular lines, opposite reciprocals. For A, example 4A, we're writing an equation of the line that passes through negative 3, 1, and is perpendicular to the line y is equal to 1/2 x plus 3. So our slope for this line y is equal to 1/2 x plus 3 is 1/2. So the opposite reciprocal of that is negative 2. So we're going to use that slope and the point, negative 3, 1, and plug it into point slope form. So y minus 1 is equal to negative 2 times x minus negative 3. The two negatives turn into positives, so y minus 1 is equal to negative 2 times x plus 3. Again, we're going to put it into slope-intercept form, since the one that's given for us for the other line is in that same form. We're going to distribute the negative 2, so we get y minus 1 is equal to negative 2x minus 6, and then we just add the 1 to each side to get y by itself, and y is equal to negative 2x minus 5. For B, we're writing an equation of the line that passes through negative 3, 5, and is perpendicular to the line y is equal to negative 3x minus 1. So our slope of this perpendicular line is going to be a positive 1/3. Again, we're going to use that negative 3, 5, so y minus 5 is equal to 1/3 times x minus negative 3. A minus negative turns into a positive, so y minus 5 is equal to 1/3 times x plus 3. We're going to distribute the 1/3 to get y minus 5 is equal to 1/3 x plus 1, and then move that 5 over and add it to both sides. So y is equal to 1/3 x plus 6. Example 5a tells us that the position of a helicopter search and rescue crew is shown on the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. So we're writing an equation for that red line. So we can first find the slope of that red line, and we would have that first point, that 14, 4, and then we are going to look at another point that goes through a vertex, which is here at that 12, 1. So from here, we're going up 2, or sorry, no, we're going up 3 and to the right 2. So our slope of this red line is 3 over 2. We're using the point 14, 4, because we don't know the y-intercept yet. So y minus 4 is equal to 3 over 2 times x minus 14. We're going to distribute the 3 over 2 to get y minus 4 is equal to 3 over 2x minus 7 times 3 is 21. From here, we add the 4 to both sides and just have y is equal to 3 over 2x minus 17.